Welcome to our Maths and Statistics revision program. Let me just show you how our revision program looks like. We have 4 days of intensive revision looking at all the topics that has been covered in class and all the topics that you have read in the syllabus. After our 4 days of intensive revisions that will run from the 12th up to the 18th of May 2020, we intend to have our first mock examination scheduled for the 19th of May 2020. After that first mock, we'll have a day to review the mock exam. That will be the 20th of May, and the 21st of May you will do your second and last mock exam that I will be able to review on the 22nd of May 2020. We intend to conclude our intensive revisions by the 22nd of May if everything go according to plan. But if there are changes that will be made, those changes will be communicated to you via our WhatsApp group, and even after the revisions are done, I will still be available to respond to your questions and queries that you may have until we make sure that you are fully ready for your exams that are coming up next month in June for quantitative analysis DA2 and Maths and Statistics 1.2. Having said that, I intend to start looking at the first part that we are covering in our intensive revisions. That's the part concerning probabilities and uncertainty. Probabilities and uncertainty. I'll break down probability topic into about 3 different parts. 2 parts will be dealing with probability distributions, and 1 part will be dealing with the simple probabilities. So amongst the probability distributions, we'll have 1 particular video specifically for the normal probability distribution, and then the other video will specifically talk about the binomial and the Poisson. Then the last video, which will be probability part 3, will be talking about simple probabilities. So let's start with the probability part 1, talking about normal probabilities. Coming from the probability distributions, there are 3 different probability distributions: binomial, Poisson, and normal distributions. And one of the major challenges that students always face in exams is to decide which type of probability distribution to use for any given particular question. Normal distributions are easily identified because most of the questions that are talking about normal distribution, the question will state that the distribution is normal, or they will give you a clue that suggests that you are dealing with normal probabilities. So the biggest challenge is on distinguishing between binomial and Poisson distributions. I'll be able to explain that in our probability part 2. So let's focus on the normal distribution. The characteristics for the normal distribution is that normal distribution, the distribution forms a symmetric curve. It's a bell-shaped curve. So when you plot the data for the distribution, you must end up with a bell-shaped symmetric curve. And at the center of that symmetric curve will be the value of the mean, median, and mode. So in other words, we are saying under normal distribution data, the mean, the median, and the mode are of the same value. They all fall right at the center. So we have the mean for the distribution right at the center of that symmetric curve, something like this. So at the center where we see 0 there, that's the position for the mean of this particular distribution. Other things that you need to understand under the normal distribution is that we use the standard scores, which are called the z-scores, to help us to calculate the probabilities. And the probability in this case is just the area under the curve. So if the area under the curve equals the probability, so the total area under the curve will be equals to 1 or 100%, representing total probability. So if the total area under the curve is 1 and the mean is right at the middle of that symmetric distribution, then it means that we have the total area of the distribution divided into 2 equal parts, and these equal parts are on the left side we have 0.5, on the right side we also have 0.5, totaling 1. For us to be able to pick the actual probability, we use the normal distribution table. The normal distribution table looks like this. Normal distribution table looks like that. It's the standard normal Z table or standard normal distribution table. The numbers you see in bold in this table represents the z-scores or the standard scores. Those are the values on top and on the far left here. The values you see inside the table here represents the actual areas under the graph, and these are the probabilities or the proportions, the probabilities for any given z-score. So, having said that, we are ready to start. The formula for calculating the standard scores, z-score, is x minus mean over the standard deviation. So let's look at some exam type questions and see if we can practice how to calculate or answer normal distribution probability questions. So to our question page, I've got a number of questions, about four questions picked from different past question papers. These are specifically selected questions that are coming from probability normal distributions. So let's start with these questions from CA 1.2 June exam 2018. CA 1.2 Business Statistics for 2018 June final exam. The first question came in section A, that was 1.5. It says if z-score of a normal distribution is 2.5, mean of the distribution is 45, and the standard deviation of the normal distribution is 3, then the value of x for the normal distribution is, you have to choose from those options. Now, what you see here is that you've been given the z-score value and the mean value and the standard deviation value, so you can easily calculate the x value. Just pick the formula for z-score and replace the values that are given in the question and solve for x. So z-score formula is z equals to x minus mean over standard deviation. So x minus mean over standard deviation. That's the formula, x minus mean over standard deviation. So let's replace the values that we've been given in the question. We are given z-score is 2.5. That will be equals to the value of x. We don't know, that's what we are calculating, but we know the value of the mean is 45 and the value of the standard deviation is 3. We know from our simple mathematics understanding that when a fraction is equals to a fraction, you cross multiply. So we are going to multiply x minus 45 by 1 and 3 multiplied by 2.5. So this is going to be x minus 45. X minus 45 equals to 3 multiplied by 2.5, that will be 7.5. Make x the subject of the formula. We will shift 45 to the other side of the equation, and when any number crosses the equal sign, the sign changes. So the negative sign will change to a positive sign. So x will be equals to 7.5 plus 45. What will be the value of x? X will be equals to 52.5. That will be the summation of 7.5 and 45. So x is 52.5. So the correct option for this question is C. The value of x should be C. Let's move on to the next question. This was coming from the same question paper, 1.2 June final exams. This was question 4 part B. Question 4 part B. It was observed that a manufacturing industry had salaries of employees which were normally distributed. So like I said, whenever you're dealing with normal distribution, there is always a crew. So it's easy to identify normal distribution because you'll be taught that this is normal distribution. So normally distributed with the average of 14,000. The average of 14,000, that's the mean of 14,000, and the standard deviation of 2,700 required. Calculate the proportion or percentage of employees who earn less than 12,000. Employees earning less than 12,000. Let's put the solution just there. How do we calculate the percentage of employees earning less than 12,000? So we have learned from the characteristics of a normal distribution that normal distribution data will always form a symmetric curve, and so we can use the same ideas of symmetric curve to help us calculate the probabilities. So let's say that's our symmetric curve there, right? So the mean is right in the middle. That's the position for the mean in this distribution. So let's put up the mean there. Let's put up the mean. We are taught from the question that the mean is 14,000. That's the average. The mean is 14,000. Our x value will be 12,000 because we are looking at the proportion of employees that earn less than 12,000. 12,000 is going to be on the left side of the mean. Logically, that's the way it's supposed to be. 12,000 on the left. So let's create a 12,000 mark. Let's say our 12,000 mark is there. So what are we looking for? We're looking at the proportion of employees who earn less than 12,000. So less than 12,000, you're looking at the left side of the distribution. The left side of 12,000. That's the required region. What we had established from our introductory comments is that the distribution or the curve is divided into two equal parts. Total probability is 1, so each half is 0.5. So if you look at the right side of the mean, that's 0.5. On the left side of the mean, that's also 0.5. If we calculate the area under the curve using the z-score, that z standard table will give us the area between the x value and the mean. So if we use our z-score to get the area from that table, we'll get the area between 12,000 and 14,000. So we need to finally say 0.5, which is the left side of the mean, 0.5 minus the area between 12,000 and 14,000. Whatever will remain is the area below 12,000. So let's do that. Formula for Z. Let's just pick that formula. We've already written the formula there. So formula for Z, put it there. So what's the value of X in this case? The value of X is 12,000. What's the value of mean? Mean is 14,000. What's the value of standard deviation? We are told standard deviation is 2,700 as per question. 2,700 there. So what will be the value of Z if we do that? The value of Z will be 12,000 minus 14,000, that's negative 2,000 divided by 2,700. That should give you something like 0.74. 0.74. And so what's the probability that relates to that Z score? Probability that relates to that Z score. We go to the standard normal table to get the actual area that is represented by the standard score of 0.74. This is the negative Z. Negative Z because we are dealing with the left side of the distribution. If you're dealing with the right side of the distribution, that is going to be a positive Z. So Z on the left side is negative, Z on the right side of the distribution is positive. So go straight to your standard normal table. Standard normal table. Row number 0.7 because our Z score is 0.74, so we are in row number 0.7, row number 0.7, and then column 0.04. So row 0.7, we have it there. Column 0.04, column 0.04, we have our column 0.04 there. The value that we get here is the area between our X and the mean, and so that probability is 0.2704. That's the area between 12,000 and 14,000. What we're looking at is the area below 12,000. So we are going to say this entire area, which is 0.5, minus the area between 12,000 and 14,000, what will remain is the area below 12,000, and that's going to be our probability for earning less than 12,000. So let's just do that. So the probability of X being less than 12,000, X being less than 12,000 is equals to 0.5 minus 0.2704, which is the value that we have there. This is going to be equals to, tap that in the calculator, you should have 0.2296, 0.2296. So that's the probability of earning less than 12,000. So calculate the proportion of employees who earn less than 12,000. The proportion of employees who earn less than 12,000 is 0.2296. If you convert that to a percentage, you should have 22.96% of the employees are earning less than 12,000. Okay, so let's move on to the next question. The next question says, calculate the proportion of employees who earn more than 11,000 and less than 19,000. In other words, you're looking at the proportion of employees that earn between 11,000 and 19,000. So let's look at the percentage of employees that are earning between 11,000 and 19,000. So there we go, our solution. When you are just beginning, if you are a beginner in this area, always put up the graph. I advise that you put up the graph so that you can see how the symmetric curve is divided into different portions until you gain enough experience where you can calculate without putting up the graph. On the other hand, putting up the graph is a way of trying to explain your answer. So it's just important that you put up a graph and then you begin to work. So let's start. Our mean is 14,000. We know that. That's our mean, 14,000. We are looking at x 11,000 to x 19,000. We're looking at employees earning between 11,000 and 19,000. So just create those demarcations in your symmetric curve. Let's say that's our 11,000 mark, and that's our 19,000 mark. 19,000 mark. Let's put it there. 19,000 mark. We are looking at the proportion of employees earning between 11,000 and 19,000. So the area that we are interested in is this area from 11,000 to 19,000. So this is very easy. So what proportion of employees are earning between 11,000 and 19,000? Just get this area plus that area. So let's start. Where is our Z-score formula? So pick your Z-score formula. Beginning with the left part, your x is 11,000. Your mean is 14,000. Your standard deviation is 2,700. 2,700. What is the Z-score? Z will be equals to 11,000 minus 14,000, that's negative 3,000 divided by 2,700. You should get 1.11. What's the probability relating to that value? What's the probability relating to the Z-score 1.11? We are in row number 1.1, column 0.01. So 1.1, we found it, row number 1.11, 1.1 under column 0.001, 0.01. So the value we get there is this one. So pick it. That's the value we're getting there. Bring it down there. That's the probability relating to that particular Z-score. What this means is this is the area between 11,000 and 14,000. Let's calculate the area between 14,000 and 19,000. We use the same Z-score. So let's see, x in this case, x is going to be 19,000. The mean is 14,000. The standard deviation is 2,700. So what will be the Z-score? 19,000 minus 14,000, that's 5,000 divided by 2,700. You should be able to get 1.85. So 1.85. What's the probability relating to that Z-score? Probability relating to that Z-score. Remember that Z-scores are given to 2 decimal places because that's all you need to pick the probability values from the table. So we go to row number 1.8 under column 0.05. 1.8, that's there, under column 0.05. If we have found 0.05 there, right? So the value that we have here is 0.4678. Pick that value That's the probability you're looking for. And that, of course, the area between, that's the area between 14,000 and 19,000. So finally, you can conclude by saying, what is the probability of 11,000 being less or equal to X being less or equal to 19,000. That's how we write it. 19,000. We're looking at the probability of all the proportion of employees that are earning between 11,000 and 19,000. They fall within these brackets. So all you need to do to find the area for that required part, just add this area. Let me pick it from here so you can see it clearly. Add that area plus this area plus that area. So when you do that, your final answer is going to be so you should get 0.8343 0.8343. So 0.8343. This is the proportion of employees that are earning between 11,000 and 19,000. As a percentage, you can as well write it as 83.43%. 83.43% of the employees are earning between 11,000 and 19,000. Let's move on to the next question. This question 6 coming from the same examination paper, so you notice how important normal distribution is for those that are doing CA 1.2 business statistics. Very, very important. So let's move on to question 6. A population is normal with a mean of 40 and the standard deviation of 8. If one item is taken randomly from this population, find the probability that it is greater than 55. Less than 32. So let's see how we can answer these questions. Same things, same ideas, same things that we are doing here. Put up the symmetric curve. It will guide you to come up with those proportions. Wow. So let's see how we can put up a proper symmetric curve. Proper symmetric curve. Right, we have it there. The mean value right at the center of these this proportion, or sorry, this curve. So let's put up the mean. We are told from the question that the mean is 40. So we have the mean 40. We're looking at greater than 55. Greater than 55. 55 is on the right side of 40. So put 55 there. Create a mark for 55. So 55 as a part. So we're looking at the probability of greater than 55. Greater than 55, you're looking at the right side of 55. So that's the area of concern. Right side of 55. So let's calculate. Of course, the table will give us the values between X and the mean. So let's calculate using our z-score formula. So z-score formula, put it there. What's the x value in this case? The x value is 55. What's the mean? The mean is 40. What's the standard deviation? Standard deviation is 8. Standard deviation is 8. That's 8 there. So the z-score will be 55 minus 40. That's 15 divided by 8. You should be able to get 1.88 rounded off to 2 decimal places. That's 1.88. What's the probability relating to that z-score? Probability is going to be equals to, we go to the normal table to get the actual area between 40 and 55. Row number 1.8 under column 0.08. Normal distribution, row number 1.8, column 0.08. That's the column 0.08. We pick the value there. This is 0.4699. That's the probability that relates to that area. And what this means is that this is the area between 40 and 55. That's the area between 40 and 55. But what we're looking at is the area beyond 55. That's a probability of greater than 55. So we'll say probability of x being greater than 55, probability of x being greater than 55 will be equals to, we have the entire half of the distribution as 0.5. So if we remove from 0.5, we remove 0.4699. What remains is the area we're looking at. So you will say 0.5 minus 0.4699. What we get there, tap that in the calculator, you should be able to get 0.0301. So that's the final answer that you're looking at. Let's look at the part 2 of the same question, part 2 of this question. Part 2 says probability of less than 32. A population is normal with a mean of 40, standard deviation of 8. If one item is taken randomly from this population, find the probability that it is less than 32. Same things, symmetric curve is needed, less than 32. Remember, I've already said that when you become an expert, you can still calculate these probabilities without putting up a graph. But when you are just starting, these graphs are quite helpful. So put up the mean, we are told the mean is 40. Mean there 40. That's the mean as per question. 32 is on the left side of 40, so put 32 mark on the left side of 40, and so that's going to be your 32. Use the z-score to calculate the area between 32 and 40 and then see whether you need to subtract or add. The question says less than 32, so the area you are interested in is this area, less than 32. So z-score formula, that's our z-score formula. So let's substitute. What's the x value? X is 32. What's the mean? Mean is 40. What's the standard deviation? As per question, the standard deviation is 8. So what will be the z-score? 32 minus 40, negative 8 divided by 8, that's negative 1.00. So minus 1.00, that's our z-score. Remember, z is always negative when you're on the left side of the graph of the symmetric curve, and z is positive when you're on the right side of the symmetric curve. So don't worry about the negative, positive issues. The z values that you get from the table will just be the same. So let's see what probability relates to this z-score. Probability equals, we go to the table, row number 1.0 under column 0.00. Row number 1.0, we found 1.0 there, under column 0.00. That's a column 0.00, and the value we get there is that 0.3413. That's probability 0.3413. And so that's the area between 32 and 40. So what's the probability of picking an item that is less than 32? Probability of picking an item that is less than 32 is the probability of x being less than 32. Probability of x being less than 32. So we'll get 0.5 minus this area, whatever remains represents the area below 32. So we get 0.5 minus 0.3413. 0.3413. So tap that in the calculator. How much do you get? Tap that in the calculator. How much do you get? You should get 0.1587. 0.1587. And that's a final answer. So if one item is taken at random from this population, find the probability that it is greater than 55. The probability is 0.0301. Find the probability that it is less than 32. The probability is 0.1587. Let's move on to the next question. The next question came in the quantitative analysis paper for June 2018, DA2. Question 1.7. The average price of a blanket in a shop is 100 and the standard deviation is 15 kwacha. The price of blankets are normally distributed. Again, here we go, normally distributed. With normal distribution, you are always taught, at least 99% of the question you'll be taught, this is normal distribution. The probability value of a blanket with the price not more than 122 is, the price not more than 122 means less than 122 or less, not exceeding 122. So it's 122 or less. So let's see how we can solve this particular question. Symmetric curve first. Until you feel you are so used not to use the symmetric curve to find answers. But for now, meanwhile, take advantage of the symmetric curve. Always put up the symmetric curve. It will help you a great deal in finding answers. Put up the mean. What's the mean? As per question, the mean is 100. So we have the mean of 100. Not more than 122. 122 is our x. So 122 is our x. Right. So not more than 122 means it's 122 or less. So the area we are looking at is the area on the left side of 122. We know that this other half of 122 is 0.5. That's what we had established from our introductory comments. That half is 0.5. What we don't know is the area between 100 and 122, and we can easily calculate that using the z-scores. So formula for z-score, what's the x in this case? The x is 122. What's the mean? The mean is 100. What's the standard deviation? The standard deviation as per question is 15. Standard deviation is 15. So what will be the z-score? 122 minus 100, that's 22, divided by 15. 22 divided by 15. 22 divided by 15, that will be 1.47. 1.47. And what probability area is attached to the standard score 1.47? We go to row number 1.4, column 0.07. 1.4, column 0.07. So we have our 1.4 there, column 0.07, that's a column 0.07. We pick our value there, that's a 0.4292, 0.4292. Okay, so 0.4292 is the area between 100 and 122. That's the area between 100 and 122. So let's calculate. Final answer will be probability of x being less or equal to. Probability of x being less or equal to 122 is going to be equals to, you know exactly what we need to do here. We are not subtracting, we are adding. Okay, so we are adding 0.5 plus 0.4292. 0.5 plus 0.4292. And the final answer will be 0.9292. That's a probability of not more than 122 or less. Alright, so we've come to the end of our first video revision, probability revisions, and we have looked at normal distribution of the probabilities. In our video number 2, we are going to look at the binomial and Poisson distributions, and the video number 3 will be winding up on our probability revisions by looking at the simple probability concepts. Thank you for your time.